Forward. Awesome. Okay. So here we go. So when you verify trig identities, now before I get too carried away with this, and you don't have to write this down. Just relax for now. What if I have this here? 2x plus 2 equals 4. That's an equation, right? Why do I call that an equation? What makes it an equation? Equal sign, totally. And what do we do with equations? We solve them, right? We solve them. And I know you guys can solve this, right? So x equals 1. Easy. Easy peasy, right? Now, let me do something like this here. Now, some of you guys might think this is an equation if you see an equal sign. It's actually a special equation. It's called an identity. So identity or things like identical, right? What's going to happen here is that the left side is identical to the right side. Should get my stylus back. It's broken right now. To the right side. Do you guys see why the left side is identical to the right side? Well, that's what it's 2. What do you got? 2. What's on that side? It's identical. It's a mirror. It sees itself in the mirror, right? It's like your identity, right? Like you know who you are. I know sometimes you think of identity like identity theft or whatnot, but this is more about being identical. The left side is identical to the right side. So, what value makes this work? Is there a particular value or anything? Can I plug in any number of the work? Yeah, it's infinite. There are infinite possibilities. X could be 1.37. X could be negative 5.82. I just have two random numbers. So it's identical. That's what we're dealing with here. These are not equations necessarily. These are identities. And what do we do with identities? We prove them. You don't solve, you prove, because there's no value. Solving is a waste of time, because guess what? The answer is going to be any real number. It won't matter, right? You're going to prove or verify. Just like if you were to sign up for something, like you guys are filling out college apps, like you have to do ID verification for these college, I assume, right? Yeah, you got to put like your ID or whatnot. Yeah, you got to verify. They got to prove that you say who you are, like your address and your birthday date of birth, your social security number, all that stuff, right? So yeah, we got to prove these. We got to prove the left side equals the right side. Okay, that's my little spiel on this. Now let's actually do it. And one thing that we want to think about too, we're only going to work on one side. Because you work on two sides, it can get very messy, and it's hard to figure out where you made a mistake. Plus, I'm going to force you guys to work on one side so you can use all the formulas on the sheet here. And still the same thing. Anything that's not sine or cosine, make it sine or cosine. Try factoring, try fractions, try a bunch of stuff. And the side you should work on should be the side that's more complicated. I think it's pretty clear what side's more complicated for this example here. The right side, right? Let's work on the right side. So this is a very standard one. So what I'm going to do, just because I'm lazy, I'm just going to put double quotations to show I'm repeating one side. You can write tan theta over and over again if you want, but I'm going to just do that. That's just my out of habit. And sine theta, of course, is sine theta. There's another way I could write secant theta. What's the other way I could write secant theta? According to our formula sheet. 1 over cosine. Thank you. 1 over cosine. And then you get sine theta over cosine theta. Now, looking at our formula sheet again, do I see sine theta over cosine theta on my formula sheet? Where do I see that? I should see it somewhere. On the bottom, yeah, equals what? And what is and equals tangent theta? Perfect, got it. Yep, there you go. And now it's verified. Because now you got the left side looking like the right side. 3-step process for this one. Oh, hey, Liam, how's it going? We're just starting notes. So, yeah, we just went over the homework. I'll post the school. You can look at it later. Okay, cool. We're good? All right, let's keep moving. Okay, example 8. And whatever your gut tells you. Now, I'll tell you right now, when I do these problems, sometimes I don't know what's going to happen. I just take a chance. Like, I don't know. Let's find out and try something. So you want to be persistent, right? That's a good attribute just in life in general. Be persistent. Sometimes it'll just fall into place. But I mean, right now I can't see steps A, B, C, D, E, F all in advance. I just don't know. So what side do you think we should work on? It should be pretty obvious. We're gonna work on what side? Left. And what technique we can actually use? That's my first step. Foil, totally. Yes, totally agree. 100%. So let's do it. So we're gonna foil. And I'll just write one. I don't have to write double quotations. One's easy to write. But you foil, you gotta do this. First, outside, inside, last. So there we go. Cosecant squared. I'm gonna need more space, so I kind of goofed. I'll write the one later. Cosecant squared theta plus negative cosecant theta times cotangent theta plus cosecant theta times cotangent theta minus cotangent squared theta equals 1. Okay. Hopefully you guys can see that. It's a little messy. But yeah, that's cotangent cosecant, negative cotangent cosecant. What happens to those middle expressions? Fully cancel, right? As they should. Fully. So now you're stuck with this. And by the way, please don't cut corners. I know, and then I guess sometimes like, you know, we what's the right word to use? Sometimes we get not say excited, but like we see what's happening, right? So we want to jump to the answer really quickly. So we figure, oh, that works and that works, and so we wind up like combining 2 or 3 steps into one. Take a deep breath, show each step very carefully, right? So rewrite what's left. Don't just try to do all this stuff in one line. Take your time. Be detail oriented. It's totally okay. Be a little OCD here. Okay, so I write again. Now, this is where my form sheet's gonna be my best friend. I'll be honest, I don't remember these off the top of my head, so I gotta look at the formula sheet. Okay, so here's my formula sheet. Let me clear the screen for a sec. Okay, do I see some of the cosecant and cotangent? I do. And what happens when I move the cotangent to the right side? It becomes negative, right? It's cosecant minus cotangent. What's cosecant minus cotangent? 1. So now let me redo that. There we go. It's gonna be 1. So it's verified. So now I'm just gonna write 1 equals 1. And it's verified. There you go. So again, that's just what's about 3 steps. So most of the identities, we'll try to keep it kind of tame. Occasionally some that are kind of crazy. We're gonna do some crazy ones. The quiz that we'll have on Friday of next week, I think this can be 2 or 3 questions. There'll be one easy identity, one that's maybe a little more challenging. This is I consider these to be the easy ones. Let's now move on to the hard ones. So let's go to 5.2. So you guys know the story, what we're doing. We're just gonna jump right into it. So let's move on to, so if you guys can go to 5.2, I guess I have a thick copy, so let's go to the 5.2 notes. And we have 5 more examples to do. I think I'll do one more with you guys, and I'll have you guys try some on your own. So for example 1 of 5.2. Okay, don't do this. Do not do this. I have some students that will do this. They'll say, oh, sine squared x plus cosine squared x plus sine squared x plus cosine squared x. 1 plus 1 equals 2. Okay. We will get this eventually, but what mistake do you think I just made? I distributed the exponent, right? We just had this discussion, right? You can't distribute exponents. You can't just say, oh, well, 2 plus 3 squared is 4 plus 9. Of course not, right? What's 2 plus 3 parentheses squared? What's that really? It's 25, yeah. So you can't distribute squares. You actually have to flip. So please be careful about that. Granted, the last 2 steps are correct, but we can't do that. So this is what you want to do. And trust me, I will design a problem where if you do make a mistake, you won't get the right answer because I want to force you guys to do the algebra correctly. It's a pain in the ass, I know, but we have to do it. So Sine x plus cos x. Here we go. Right? So all I did is I just repeated this, right? That's what square means, right? Just repeated. Now you got FOIL twice, right? FOIL twice. So first, outside, inside, last. So you should get sine squared x. And I'm just going to kind of skip a step. And remember, when a trig function is squared, when you multiply a trig function by itself, we write sine squared x or cosine squared x. It means it's being multiplied by itself. And then I'll do the other one in blue, so it stands out. Sine, boom, boom, boom. Sine squared x. Okay. Yeah, I know what we did earlier worked, but it wasn't the right algebra. This is the right algebra. Now, do you think you see things cancel here? Negative 2 sine x cos x and positive, right? Those cancel. Right? And what are you stuck with? What we had before. Sine squared x. And again, don't cut corners. 1 plus 1 equals 2. 2 equals 2. And we're good. That's the right way to do it. Now the left side equals right, so we verified it. So this implies that anything for x would make this work, right? But we just have to verify that the left side equals the right side. Okay, any questions? No, we're good? All right, so here's what we'll do. I'll give you guys a little push on the next two examples. I'll walk around and help you guys out. What I want you guys to do is work on the left side. And convert tan x to sine x or cos x, and convert cotan x and here work on the right side. Use the even odd formulas. Then change cosecant and secant to sine or cosine. So give you guys some hints. Once you guys get to it. And I'll see how you guys do. Oh, you're up there too. Okay, just realized. George did that. Was very nice of him. I guess that's probably Miss Decker because the handwriting is much nicer from real sparse. So. That's very nice. Okay. Oh my God. I could do hard math. I don't know my left or right. My 7-year-old son struggles with it too. Now I know why, because he gets from his dad. So, oh goodness. Wow, that was rich. Thank you, Liam, for correcting the teacher. Right side. Oh my God, I did it again. Wow. What is wrong with me today? It's Friday, dude. I'm like just excited for watching football this weekend. My head's somewhere else. Here we go. Sorry about that. Okay. Yes. Work on the right side for example 2. Work on the left side for example 3. Yeah, sure. Sean, right? Yeah. Not yet. Not yet. Yeah, so what you're going to do is convert that to sine or cosine, cosine or sine. Okay. Then combine those two fractions. Okay, I'm gonna freeze the screen and start working it out, and I'll come around and help you guys out once I have it worked out myself.
So the bottom. You're doing now something. So.
All right. Yeah, I got these worked out. Let me just see how you guys doing. Oh, you're show me the example. So you got these. Good. Great. Awesome. Good work. So show me which one you're about. Which one you're about. Yes. So four. Yeah. Yeah, I work on the left side. I'd actually factor it first. It's actually much easier. It's different square. So what you're gonna do is you're gonna so when you have this here, it's not terribly obvious, but if you have something like this.
So it should be.
Oh.
So use something like that. That'll help. Any questions so far? Nothing else is a plus, unfortunately. So you gotta combine the press. So you gotta find the LCD, which is like sine cosine. So then you multiply this by sine of sine.
No.
No, for sine, actually, I'll make cosine of sine. Because cosine is 1 over sine.
Yeah, we
Multiply
have
by-
it as.
So then it would be.
And
then cosine.
it might be easier to make it cosine. And look at the other side, we have cosine.
Yeah,
So I probably want to keep the cosine there. Yeah, technically you're right.
but I was gonna undo it.
You can do it back later, sure. That's fine.
Yeah.
Nice. You want to, what was that? Was that this year?
Wait,
That's awesome.
I would have to.
Any questions so far? Yeah, this looks good. Good, excellent. Yeah, combined, perfect. Good. Good job, yeah. So number, yeah, this next example, just
No, you have
use
to
a,
flip it, so
you know.
yes.
Yeah, that's what I. Already done your guys, all three of section.
So we got here.
That's
Not.
the bottom. You add them together and then you have.
I guess like this. Yeah. Okay, so first of all, it's some percentage.
Oh, that's
Right,
right.
but even then, there's a plus there, so you're toss things off. What you want is actually combine two strategy interest. Okay, and the LCD.
These go together, these have to get added.
So then you got multiplies by sine and sine. Multiplies by cosine, cosine.
Then you make it the same.
Yeah, it's in denominator minus. I think this one you're on the right track. Yeah, what you don't want to work, leave the right side alone.
Then you have.
It's the left side, and then you're gonna change it to a tangent afterwards. But here's this one thing though. This would be after you do the sine negative theta, it's actually.
So once again,
negative.
it's Oh, wait.
And take that cotan, and that'll be negative cotan. But you're on the right track. Okay. You guys are great. You good? Okay. So it's just like, yeah, so this is good. That's fine. Yeah, that's exactly what you want to do. Yes, good, good. And so that becomes one. Sine squared plus cosine squared is one. So no, you're on the right track. You're doing great. Yeah, what's happening? Square the x.
101 over
Cosine x.
1 over
Times cosine x times sine x all over one. Now, these cancel. Boom, that's- yeah, you're almost there. Yeah. How are we doing here? Yeah, you got it. Yeah, good. Only thing, you know, just make sure you show that that's negative.
this right here is equal to 1.
No, no, no.
This equals
No, 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 it's not plus there. Yeah, then you make both.
You'll be okay.
How does it?
Sign it, something about it.
How are we doing?
Oh, it's.
Yeah, but only thing. So that gets us actually backwards. We don't want to do that. So no, this is good. I would erase that the new line, but this is good. You want to focus on this because then the top becomes one. Oh. And then up top you have cosine over sine, and then when you flip, so I'm gonna show the class in a sec. Okay, you guys are doing fantastic. Really happy with how you guys are doing this. Let me show you guys the answers now. Here we go. Here are the answers. Okay, so but I really like what you guys are following the protocol, just incredible. That's great. So you guys convert cosecant 1 over sine. That's great. You convert these. That's great. And then you saw an opportunity to combine fractions. Fantastic. That is a key step. You saw that opportunity. You took it. That's great. When you combine these two, I kind of skipped a step. When you combine these two, you multiply top and bottom of this one by sine x, and top on this one by cosine x, cosine x. So then you wind up getting this sine squared x plus cosine squared x over cosine x times sine x. Now this is an identity. That's one. So that's one over that chunk. And the top is just cosine over sine. We have two fractions. You divide the second fraction. Sorry. When you divide fraction, you flip the second fraction. After you flip it, the signs will cancel. You get cosine squared x. The signs will cancel. I think this one's probably a little easier. This one is negative cosecant theta, and that's just secant theta using your formula sheet. And that's negative 1 over sine theta, it's 1 over cosine theta. Flip the second fraction over, that's negative cosecant theta. So I'll let you guys simmer on that for a little bit. And again, there'll be a recording of this. So, okay, and I'm somewhat staying true to my word. It's 9:03. I'll be able to get this done by 9:10. You'll have a half hour to start homework. Okay. Yeah, good. Yeah, fire away. Yeah. Actually, yeah, you could. That's actually, wait a second. You know, you're not wrong in doing that. It's not quite showing all the steps. Yeah, I mean, probably cost you a point. Yeah, because it's not showing all the steps clearly. Because, I mean, yes, after you do this enough times, you can see that. But you might want to kind of just show that cosecant 1 over sine, secant 1 over cosine, then flip it. So, all right, example 4. So now for this one, I wrote on the board here a kind of a conjecture in a way. If you have something raised to the 4 power, don't freak out. Treat it like a quadratic, because you guys know this. Back in the day, you guys done x squared minus y squared is x minus y, x plus y, right? Right, you know that. So it's kind of the same thing, and that actually would work on the left side. The left side's more complex because you do have those 4 powers. So let's actually work on the left side. And now I know the difference between left and right. Okay. So cosecant squared x minus cotan squared x, cosecant squared x plus cotan squared x equals the other side. Okay. Now I'm going to go back to my form. Actually, I'm going to look over here. So very glad that this did it. It's Miss Zephyr, yeah. There we go. I see this, right? Cosine squared minus cosine squared 1. I see that. Great, awesome. Done. 2 steps. That was lovely. 2-step problem. Because if you work on the right side, you're going to spin your wheels because you're not sure where to go with that, right? I'm just being a little more detail oriented by just writing it again. Because 1 times anything is a self, right? So there you go. So just use the difference of squares, right? Use your identities to substitute, and voila, you have the answer. So that's pretty easy. That's lovely. I love when problems near the end work out nicely. Okay, we're good. All right, and the last one. Actually, we'll give you a sec if you're still jotting it down. Yeah, go ahead, Sean. Number 3, yes, go back to number 3. Cosine theta, wait. Okay, so the top becomes this, negative cosecant theta, and the bottom just becomes secant theta. That's just using our formulas. That's negative 1 over sine theta and 1 over cos theta, right? And then you flip the second fraction, which becomes cosine theta times negative sine theta. No, only the top one's negative. Secant here. Secant negative is just secant theta.
Oh.
The reason why is because on the unit circle, if you go like say clockwise 30, counterclockwise 30 degrees and clockwise 30 degrees, those are gonna be the same coordinates. They're gonna be, and secant's just 1 over x. So they'll always, regardless of what direction you go in, if you go the same magnitude of, like 120 degrees one way, 120 the other way, they'll always be the same thing for cosine or secant. All right, last one. Let's finish strong, guys. Okay, this one, I'm kind of torn with this one here. I think you can work on either side, to be honest. I think my gut tells me to work on the left side, just because I can convert just fine cosine. So I'm going to work on the left side. You could work on the right side. If you work on the right side, guys got this. You could do something like that, but I'm not sure if that's going to be a wise approach. Because usually we don't want to change sign to secant to tan. It's not hard to do. So I'm gonna work on the left side just because I don't see sine or cosine. So, but sometimes you might work on the right side, just depending on the trig function you're seeing. So we're gonna work on the left side again. And we're gonna FOIL. We have no choice but the FOIL. And again, I have no idea how this is gonna look. Like I can't see all the steps in advance. I'm just gonna take a chance, see what happens, right? So we're gonna FOIL. Okay, so let's do this. Try it right now, FOIL it, see if it can make sense of the identities. I'm gonna freeze the screen and see if I can get it, and I'll walk around and see how you guys are doing, and then we'll wrap things up after that. So let's do it, guys. Oh boy. I'm gonna give you guys a hint. After you guys FOIL, convert everything to sine and cosine after you FOIL. That probably help, I think. Yeah, that will be the trick, guys. Actually, they'll come out very nicely. I'm gonna show what I have so far, so you guys don't go, because I was actually spinning my wheels just for a sec. Guess what I have so far, guys? FOIL.
I think you guys want to do that, right? That's for fun. And I convert this one to cosine squared x, convert the secant to one cosine. So then that sine cosine becomes that. And convert the tangent squared to sine squared cosine.
Because remember, secant's 1 over cosine, right? Tangent sine over cosine. So that's how I get all that right there. Okay. Yeah, I'm going to show you guys the answer in just a sec. Yeah, that's a brutal one. All right, guys,
We walk you through it. Because this is a little crazy. Foiling, I think was obvious, right? I think we're pretty clear that foiling was obvious. And then the rule of thumb I talked about, I think it's not sine cosine naked. I think that's not part 2. That's 1 over cosine squared. Secant is 1 over cosine, tangent sine over cosine combined that. It's 2 sine x over cosine squared x. And that's positive tangent squared x, so it's plus sine squared x over cosine squared x. Okay. This is the part that's not obvious. So next step. You guys probably seen this in class. If you have a squared minus 2ab plus b squared, it becomes a plus b squared. That's kind of what I did. If you have 1 minus 2 sine x plus sine squared x, that's like saying b squared minus 2ab plus a squared. It's kind of like saying that. Because if you were to FOIL this sine x minus 1, you would get sine squared x minus 2 sine x plus 1. That's a little tricky to see. It's called a perfect square trinomial because you have sine squared and 1 is called perfect squares minus 2 sine x. So you get that. And the bottom obviously is cosine squared x. Cosine squared x is 1 minus sine squared x from over here, right? That I know. I know that. And this is just sine x minus 1 times sine x minus 1 if I were to expand that. Then I factored this up top, so I did a little loop up top. Sorry. So you have 1 minus sine x 1 plus sine x. These will cancel, but because that's reversed, sine x minus 1 is 1 minus sine x, you have to leave behind a negative 1. Negative 1 times this is 1 minus sine x or 1 plus sine x. Fair. I know. It's a little crazy. Question, go ahead. Yes.
What's that?
So cancel what's our no, the positive obvious. Yeah. Nice again. Yeah, and of course it can't. There's a plus there. Anyway, yeah, that's that.
Where did the
Hmm?
1 minus sine squared x on the denominator go? On the bottom of your.
Oh, this right here? So I factored, so when I went up top, so let me do this. Let me, because I really made this incredibly messy. We don't need that anymore. And let me move the other stuff really quickly here. Okay, let me move this. Okay. So let me kind of do this one more time, guys. So we're okay at this, right?
So I have this part, right? Okay, at this. And then I have this. And then this is the part that's a little tricky. You have sin x minus 1 and 1 minus sin x.
So first off, Liam, do you see the 1 minus sine squared x? I factored it, right? Do you see that part?
From when?
Okay, so
So we had cosine squared x. Do you have that at least?
Yeah.
Okay, yeah. Cosine squared x is that.
Actually,
Right. And then I factored afterwards.
okay, yeah.
The one part that's tricky, this is the part that a lot of people get confused about. Even after speaking topics, gets confused all the time. That can be simplified. That's actually -1. That's -1. The reason why is because you can write this as -1 on the outside, x minus 1. That's all. And then those cancel, that's when you get -1. So you could do that when these are reversed with a minus in the middle, just leave behind -1. And then just do the -1 to here, and that becomes 1 minus sin x, or 1 plus sin x, and get zero. I know, it's a tricky one.
I won't do that on the quiz. I promise you. That's too much for a quiz. Maybe a test question. We'll see. Depends what mood I'm in at the end of January. If the Niners get eliminated, I'm gonna write you guys a really hard test. So that's kidding. So root for the Niners. All right. They're not playing this weekend though. All right. Okay, so we're all good, I think, for today. Let's stop